Yes, so hello everyone. So today we are starting with the concept of kinematics. Okay, so today we'll be dealing with in kinematics. Kinematics is a big chapter. So if I have to divide this chapter, I'll say that kinematics is made up of one dimensional motion and 2D, two dimensional motion. So we'll learn them separately. One dimensional motion also has some concepts like initial stage of the chapter deals with basic things: distance, displacement, velocity, speed, average and instantaneous values of the same, acceleration, constant accelerated motion. Okay, then there is also discussion about graph, then constant accelerated motion in one dimension, that is free fall of a body. Also then afterwards at the end of the chapter we'll be discussing about relative velocity in one dimension. Okay, and then comes the two dimension. The two dimensional will be having motion happening in both x and y axis. That's why two dimension. So the important concepts here comes as projectile motion. Okay, and then again relative velocity concepts in two dimension. So these are like more important concepts in the topic of kinematics. So right now in this video we'll start with the first part, the easiest part, that is we'll discuss about what is distance, displacement, etc. So let's first discuss about distance and displacement. I don't need to use the board for this. I'm pretty sure all of you understand what is distance and displacement, right? Distance is nothing but the total path length covered by a body. So basically if a body starts from the location 1, okay, and he goes to location 2 and then he returns back, right, and he returns back to the location 3. So this is location 1, 2, and this is location 3. So during this motion, let us say he covered a path length of L1, or we can say D1, from 1 to 2. In returning back, he covered a path length of D2 from 2 to 3. Then in exam, or if somebody is just asking you a question that what is the distance covered by the particle? So distance covered by the particle is nothing but the total path length covered by that particle. So when the particle started from point 1 and finally reaching to point 3, he has covered, or that particle has covered, a total length of d1 plus d2. So this would be called as the distance covered by the particle. This is the total distance. Very simple. It's basically the total path length. Okay. Whereas displacement, also again a simple quantity. It just means that what is the shortest path between the final position and the initial position. So final position of my particle is this 3. Initial position of the particle is 1. If you ask what is the shortest distance between them, because this is a one dimension motion, shortest distance would be always this distance. There is no need of calling shortest distance. This is the distance and that is also the shortest because it is one dimension. But remember the definition, it's always the shortest distance. It will be useful in two dimensional motion. So shortest distance, or just the distance between the final and the initial position, is nothing but this. This will be called as displacement. And how can you write the displacement? You can say displacement is equals to d1 minus d2. This will be considered as displacement. Basic things. If a person goes along a garden, this is like a common question. I think 9th grade NCERT also they're asking this. So if a person is moving around in a circular garden, okay, garden in the shape of a circle, he starts from one point, he completes the garden, journey of the garden, completes it and comes back to the same initial position. Then they ask what is the distance traveled by the person. Distance would be nothing but the path length, which is the circumference, and what's displacement? 0. He came back to where he started from. What if he has not covered the entire circle? What if he covered only half of the circle? Then distance would be half of 2 pi r, that is pi r, and the displacement would be the diameter, because he started from one point, completed half circle. So now the displacement, the position, the distance between the final position and the initial position, the shortest distance, that will become the diameter. So that's how we have distance and displacement concept. Once we understand that, we have to also understand that displacement is something that we can figure out or we can calculate by using always a reference. So for both distance and displacement, the most important thing that you require is a reference point, or you can say a reference frame. So this is called as my reference frame. Okay, this is a reference frame. What's the meaning of reference frame? You need a standard location, a fixed location. Fixed in the sense, it's not necessary that the reference frame should be fixed, but this is the location from where you will measure everything, that kind of a point. So this would be considered as my origin, and all distance would be measured from here. So let us say a particle was somewhere here initially. I can say that position vector of that particle, from the topic of vectors, you might be knowing this, that the position vector of a particle is always represented from the origin towards that point like this. Let me call it as R1. This is the initial position of the particle. The particle then does some motion and finally reaches, let us say, here. So now final position of the particle is represented by this position vector here, which we can call it as R2 vector. Okay. Now what is displacement? We said displacement is nothing but the shortest path between the initial and the final. So initial and final, if I talk about the shortest path, won't it be this straight line? And a general way of defining displacement can be also written in this way, that final position minus the initial position. Okay, now what's the final position? Final position vector of the particle? It's R2 minus the initial position vector R1. So this subtraction would be called as a displacement. And because it is R2 minus R1, that means you're subtracting, you're finding the change. And that's why this displacement now will be also written as delta R, because it's a change in position. So change represents delta R. So this is delta R, and delta R vector, if I want to show, then that will be like the particle went from position 1 to position 2. So this becomes my delta R vector. Okay, so please remember one very important thing here. Distance only depends on path length. Displacement depends on only the initial and the final position, and displacement can be also set as final position minus initial position, and that can be shown by this delta R. And please remember in the diagram, when it is R2 minus R1, then delta R will be drawn in such a way that the head of my arrow will always point towards the final position. Final position was R2, no? When I write R2 minus R1, first term is R2. So head should be pointing towards R2. Please remember like that. Why I am saying this? Because many a times in many questions we'll be using vectors. At that time, that simple confusion should not happen. If it is R2 minus R1, then vector head will be towards R2. If it is R1 minus R2, then vector head would be towards R1. So like that we'll be having. Okay. So please make sure to note this. Very simple concept. Now, once the distance and displacement concept is over, obviously what is the next topic that we have? The rate of change of distance and the rate of change of displacement. So rate of distance coverage is basically speed, you know that, and the rate of displacement covered is basically velocity. The difference between speed and velocity is kind of similar to the difference between distance and the displacement. Distance is a scalar quantity where only magnitude or the path length is important. Displacement is a vector quantity, as you can see, where direction as well as the magnitude is important. Same way, speed also scalar, velocity is vector, like that. Okay, so in simple way, if I have to show, I can say that speed can be defined as speed is equal to distance covered by time taken. Okay, and velocity can be written as velocity can be written as displacement covered. Now displacement can be written as a delta R, change in position, right? Delta R divided by delta T, that's the time taken. So I can basically say it as nothing but displacement by time taken. Now please understand that because I said the chapter right now we are studying is a one-dimensional motion, should I be even talking about the y-axis? I should be only talking about x-axis, right? So basically the particle will be only moving in x direction. At one time it is at this location, let us call it as x1. At some other time the particle would be here at x2. So the difference would be nothing but x2 minus x1. But that's why instead of calling it as delta R by delta T, I think we will feel comfortable if I just call it as delta x by delta T, because it is a one-dimension motion. Okay, if it is two-dimension, then definitely delta R. Okay, so that is velocity, that is speed. Now, there is one more topic coming under here. Same velocity and displacement, velocity and speed. One more topic called average velocity, average speed, and also instantaneous velocity and instantaneous speed. What's the meaning of this? Now, average velocity means on an average, what is the velocity or what is the speed? Both of them are kind of same, average velocity and average speed. Like for example, let me give you an example like this. Let us say a person is traveling from, let us say Delhi to somewhere. Let's say Delhi to, let us say he's going to Pune, for example. Let's say the distance is 1000 kilometers. Okay, not saying it is 1000. Let's imagine. So Delhi to Pune, the distance is 1000 kilometers, and he covers that distance, let us say, in 10 hours. Let's say. So if I ask you that what is the speed of that vehicle or the man, what was the speed with which he covered the distance? So you'll say, sir, it's very simple. Speed is nothing but distance by time. Distance covered is 1000 and time taken is 10. So 1000 by 100, that's 100 kilometer per hour. Very good. But I have one doubt here. Is it like always the speed of was 100 kilometer per hour? Was it like during the entire journey of 1000 kilometers, was my vehicle or was the vehicle of the person covering the distance with the speed of 100 kilometer per hour? It's not, right? Because some part there will be highway, he'll be going at a much higher speed. In some places there will be traffic jam, he would be stopping or maybe going at a very low speed. So the speed of the vehicle is not really constant. So that's why the word on an average, he traveled with a velocity or a speed of 100 kilometer per hour. Okay, so this is what the meaning of average. The other quantity is instantaneous. Instantaneous means at that moment, precisely at that moment, what is its speed or what is its velocity. A very good example for this one is the speedometer of your vehicle. When you are driving the vehicle, the speedometer will show you some speed. That speed is not the average speed for the past 2 hours or past 1 hour. It is the speed at that particular moment. The moment you change the accelerator, immediately the needle will also change. That means the vehicle, the meter of the vehicle is actually showing me the instantaneous speed at that particular moment. So I hope you understand the difference between the instantaneous, which is at that moment, and average, on an average throughout the journey, what was the speed. I hope you understand. So I'll just give you some formulas for the same. There are formulas which you should know. So average speed, the formula would be, I can call it as just V average without a vector sign. That means it's speed I am talking about. So average speed is nothing but total distance divided by total time taken. Okay, that's it, as simple as that. And what about average velocity? Same fashion, but this time we'll show it with a vector sign. That means it's a velocity I'm talking. So average velocity is nothing but total displacement. Okay, displacement divided by total time. So that is my average velocity. But there is also instantaneous. Now instantaneously, in our physics, we don't much deal with instantaneous speed generally, because in our syllabus we'll be always dealing mostly with the positions of the particle at different time, and positions or rate of change of position actually gives me velocity, not the speed. But that is why in most of the cases we will be only dealing with instantaneous velocity. So please make sure that you understand this concept of instantaneous velocity. Just a moment. Okay. Now what's the meaning of this instantaneous velocity? It is same velocity but measured for a very small duration of time. So velocity's general definition is delta x by delta t. This is the meaning of velocity, right? But this time I'm saying instantaneous. That means the time, the moment, or the time duration, the time interval in which I'm measuring this velocity is very small. Imagine like 1 microseconds and lesser than that, those kind of time. Okay, so that means I'm talking about a delta t such that the limit is my delta t is tending to 0. And in mathematics, this limit delta t tending to 0, this entire thing can be now represented by a function as dx by dt. I'm hoping that most of you are aware with the concept of basic calculus. So what I can say, this is nothing but it's a differentiation of x with respect to time. That means it is rate of change of x with respect to t. That is instantaneous velocity. Okay. Same way, in the same figure, I am having a little bit of space. Can I also talk about acceleration? What is acceleration? Average acceleration, if I talk about. Okay. If I talk about average acceleration. What is average acceleration? A average would be equal to delta V by delta T. But the same thing if I talk about instantaneous, then shouldn't I say delta V by delta T? Fine, but for a specific instant. So that means limit again delta T tends to 0. That means my time interval for which I am measuring this acceleration should be very, very small. In that case, what I get would be instantaneous velocity for that moment, like that. Okay. And this will be again converted to A instantaneous is equals to dV by dt. As simple as that. Okay. I'm hoping that this basic constant of, basic concepts of distance, displacement, average velocity, instantaneous velocity, average acceleration, instantaneous acceleration is clear to you. There are many questions that the boards, the NEET, the JEE examination keep asking about these topics. With different exam levels, the level of question might change, but the basic fundamental concept is this much. So if you understand this, you'll be able to solve many questions. I'll be taking one more video where I'll be explaining the graphical representation and some applications, some questions also on the same thing. Okay, so I hope you have understood. In the next video, we'll continue with this. Thank you.